Problem number 4. We're completing the square, and we have a number in front of the x squared term. So we need to deal with that number in front of the x squared term before we can complete the square. And what that requires us is us to divide by 6, divide by 6, divide by 6, divide by 6. Completing the square, the process, we have to have 1x squared. So we start by turning this into 1x squared. The 6 divided by 6 is 1. 12 divided by 6 is 2. 48 divided by 6 is 8. And 0 divided by 6 is 0. What we're going to do next is we're going to put all the variables on one side, the constant on the other, and add in our box. So we're going to add 8 to both sides. And we get x squared plus 2x plus something equals 8 plus something. Figure out what goes in that box. You take this value, divide by 2. It's always divide by 2, and square it. And over here, it's going to be the same thing. 2 divided by 2, and squared it. And you can see the square a little bit better in that second box. Simplify that box a little bit. 2 divided by 2 is 1 squared. Two divided by 2 is 1 squared. But we've set this up so that we can create a perfect square trinomial. So now instead of splitting the middle, we can use what we have here to factor. X squared is x times x. 1 squared is 1 times 1. And that 1 was positive. So this is going to be positive times positive. Or positive in both of the parentheses. And over here, 1 squared is simply 1. We can condense x plus 1 squared. Sorry, x plus 1 times x plus 1 is x plus 1 squared. And 8 plus 1 is 9. We're trying to get to the point where we can solve for x. So we need to undo the squaring by taking the square root. And square rooting and squaring cancel each other out, so we're left with x plus 1, don't write the parentheses, equals plus or minus the square root of 9. But as we take a look at the square root of 9, can we take the square root of 9? And we can. So this becomes x plus 1 equals plus or minus 3, which is what the square root of 9 is. So now we don't have any square root left in the problem. We can subtract 1 from both sides. And we get x equals negative 1 plus or minus 3. But we don't want to leave it in that form. We want to get exact answers. So what that means is, it means one of our answers is negative 1 plus 3. And our other answer is going to be negative 1 minus 3. And negative 1 plus 3 is 2. Negative 1 minus 3 is negative 4. And as we look at the top of our paper here, the question at the beginning, which I didn't even acknowledge, was could we have factored this? And the answer is yes. We did not end up with the square root in our answer. We did not end up with an imaginary as part of our answer, which means that we could have factored this problem.